Well, good morning. Welcome. So, my name is Jessica, and I'm going to be moderating a panel on the called Smart Deployments, and it's on the intersection of IoT and SRE. So, really excited about this. We're going to be examining the challenges, lessons learned, and best practices around deploying, testing, and troubleshooting observability and developer experience for large scale IoT systems. And we have a great set of panelists with us today. My name is Jessica. I'm a senior developer advocate at Elastic. I do a lot of IoT hobby projects and things like that, and really excited to be leading this conversation. I'm going to pass over to Ali.
Hi, I'm Ale. I'm a director of engineering here at VM. My previous experience is now with IoT, so super exciting learning from other panelists and also sharing my experience here at VM about like the differences between doing SRE and DevOps in a cloud type of solution versus IoT.
Hey all, I'm Brian Annis. I am the Director of Site Reliability Engineering at a company called Place Exchange. We operate in the digital out-of-home space. Formerly, I worked on the Link NYC project, which you may have seen walking here this morning. And IoT is, DevOps and IoT is a very near and dear topic to my heart, so I was really excited to be a part of this panel. I'm going to pass it over to Vinny.
Hi, I'm Vinny. I work for a company called Firefly Automatics. We're a manufacturer of autonomous mowers, medium scale, and we're primarily targeting automated fairway mowing. So I'm on one end of IoT, the not most complex, but more complex than like smart light bulbs or something like that. Yeah.
That's awesome. I'm so excited to kick off this conversation. So we'll get right into it with our first question, which is, how do reliability strategies differ between cloud-based systems and IoT environments, especially considering remote devices with limited compute, storage, and power? Ali, do you want to start this one?
Yeah, so as I was mentioning, in cloud solutions, you can rely almost on having infinite amount of resources, right? And internet connectivity is always available, reliable for the most part. Then a lot of the principles that you would apply when you go to IoT is not one-to-one, right? Like devices are often resource constrained. You can definitely not rely with the internet being available. So there are solutions, for example, that we apply. Computing is happening at the edge of the device, right? So you want devices to be able to autonomously make decisions without having to connect to the internet. You also want strategies to sync the data that is on the device eventually to the cloud when it's available. And there is a lot of, we have gone into the approach of having modules, which allows our users to apply their own solutions or reuse solutions that others have available in their own devices.
Cool. Brian, do you have anything to share on this one?
Sure, I'll extrapolate on a little bit. The great thing about the cloud, right, is that you can always start over. You may not want to, but you can. And with IoT, and especially DevOps for IoT, you probably can't, right? Like you may run into a situation where like you literally cannot start over because you don't have enough time, energy, and money to go touch every single device out in the field. And certainly when I worked for my previous company, it was always something in the back of our mind is that, okay, like we probably can't afford to go and touch all these devices. And so we need to have like very strict deployment practices and a large number of quality gates to make sure that every release that goes out is not our last release.
And do you have anything to add?
Yeah, all very similar things. I think one interesting challenge we have is we are dependent on cell, right? We don't have good Wi-Fi. We're dependent on satellite internet sometimes. So if we need to push an update and the customer is indoors, sorry, we have to call you and say, hey, can you bring your mower outdoors? We have an update for you, which is very unique. The other interesting thing about reliability is if there's a bad install, you have a mower stuck in the middle of the fairway when golfers need to use the fairway to play golf. So like reliability is very important. One positive thing we have is we have service techs all over the country. So if there is, we hope there isn't, but if there is a bad update, we have staff on the ground able to help us. And we benefit from that greatly.
Speaking of updates, Vinny, I'm going to call on you first because I have a lot of questions about what you just said. But which strategies have you found most effective for deploying updates across large IoT fleets, like a lot of lawnmowers, while minimizing downtime?
Yeah, so this is all very similar to cloud-based IoT, cloud-based SRE in some ways, where you can use feature flags, you can A/B testing. testing in different batches. We can literally call our customers right now and say, hey, we have something we want to try. Can we do it? And we benefit from the medium scale, right? We know all our customers. So that's awesome. No, I don't think I have anything else there. Oh, I do. So we recently had a large 2.0 update in which we had to update 2 computers on the mower and the cloud and our web stack, right? So web stack, that was done overnight. Great. For the 2 computers on our mower, we literally had to open hundreds of SSH terminals and apply the update because we haven't figured out how to rely on Cell to provide dependable updates. And I think we've only had 2 dead mowers because of that update that we fixed within a few hours.
I consider that a success.
Yeah.
Brian, do you have anything to add on this? I'm sure you have a lot of experience.
I'm just in the back of my mind thinking about some of the practical considerations for deploying a large number of updates. So I think one thing that is interesting about the space is that you have literally thousands of devices. And so if you're not careful, you can actually DDoS yourself. Introducing jitter into your update cycle, basically allowing like a random delay for clients to check in and get updates, was really critical for us to make sure that we don't overload the servers that actually host those updates. And then more materially, like having a strong segmentation strategy for those updates, so being able to roll updates to a canary fleet or to a specific customer or a specific region or a specific product family. All of these really helped us like move with velocity and confidence, and also not take down our update server.
Hey.
Yeah, we have definitely done the DDoS thing. A strong +1 to canaries, to being able to segment your like fleet, which is one of the features that we offer to our customers. Is like this idea that you have what we call fragments, which is identical like setups of configuration that you deploy through your fleet, and that allows you to stage rollouts. I think one feature that my team worked on recently that I'm very excited about is not only can you do a stage rollouts, but we introduced the concept of having like a safe window to update. So the device itself can also be configured to say, okay, now is a perfect time, the ideal conditions for me to update. So that can be obviously different businesses have different needs, right? So let's say you want your device to only upgrade when it's connected to a Wi-Fi and powered like through a plugin, then you only do that. It allows for a lot of more flexibility and really nailing down what the ideal conditions of what you consider safe is. Yeah, I would say definitely having like all of those strategies in place minimizes the risk of having dead devices.
Yeah, I like thinking of dead lawnmowers as like a good way to think about it. I'm interested in hearing from you all about how you ensure reliability when hardware components fail or have limited connectivity.
Good question.
Yeah, Ali, do you want to kick us off with that?
Yeah, I think so. I think a lot of the strategies are the device itself being able to recover, right, as much as possible. So some strategies could be, depending on your device, if you have sensors, you can have redundancy on those sensors and being able to fall back when the device needs it. Some devices, maybe if like they are resource constrained, you have strategies for the device to either shut down certain processes, stop doing certain operations, so the device can recover and then go back to normal performance. A lot of that really, I think, comes down to understanding what is your use case, what are the conditions of where you're operating, and then you get to define what reliability really means for like your specific device, basically.
Yeah, this is an interesting space because we're talking about IoT. These devices are in all kinds of different machines and possibly geographies, product SKUs, etc. So I really look at it. I'm just going to echo what you said, but I think of it in 2 specific areas. One is that, yes, on the software side, like having a self-healing and autonomous repair functionality is critical. You should always like have some sort of fail-safe mechanism to ensure that if the device does get into a bad state, it can be recovered by either the device itself or by an external process. That's kind of table stakes. And so I spent a lot of time at Link NYC, like building that functionality and making sure that if we ever did have a bad configuration management release, that the device would basically be able to detect that and reset itself to a known good state. The other thing I would say is depending on which platforms you're using, especially if you're using in the x86 world, there is specific watchdog functionality built into a lot of these machines you can use to, if that watchdog timer has been reset, the system is frozen, it's not cooperating, can actually restart itself, which is really just a key mechanism to allow reliability at the edge. Further into sort of the hardware world, depending on, again, like what life cycle your company's in and your product's in, I would really highly encourage you to build redundancy into any part of the hardware that you can afford to. And that might be like server style, like dual power supplies, or that might be multiple, like redundant real-time clock batteries, or other pieces of hardware, other like modules that are critical to your product working that you can afford to have some redundancy to ensure that specific functionality continues to work even if one component fails.
And Vinny, do you have anything to add?
No, I think I just want to touch on self-healing. I think when we first, were deploying, we would deploy and every time a customer would have a problem and we had to just restart something, right? That's very common in early development. We would literally write down, okay, I had to write, and we would track what are the things Vinny has restarted, what are the things was restarted. And then that gave us justification to work on self-healing. And I think early on, we had to build our own self-healing, like application specific. I think one early thing that we learned is, okay, you've developed self-healing, but you got to make sure you're not just boot looping all the time, right? You need to give yourself time. You need to do a back off. Yeah, that was one challenge we had, but yeah.
Actually, dovetailing a little bit off of that, what practices or tools have been most helpful in improving developer experience on IoT-focused teams? Brian, I haven't started with you yet, so I think I'm going to start with you for this one.
I'm happy to start. This is, I know I've said that a lot of this is near and dear to my heart. This is maybe like one of the most near and dear. If there was a contest, okay. Obviously, we're in the DevOps world. Developer experience is a critical part of our internal customer experience, right? You want the developers to be able to easily be able to create features and test those and move with confidence to production. With IoT, like there's an inherent physical portion of that. And so we tried to drive that capability as close to the developer desktop as possible, including literally on the desktop. So we basically built an end-to-end platform to take your feature branch from your desktop to production. And it looks a little something like this. Initially, you would have a desk side device that you could set up with your feature branch. It pulls the feature code. You're able to do all of your sort of development work either directly on the device or with other devices that device interacted with. But once you had accomplished that, when you commit, we would run that code actually against virtual devices in the cloud. So we would mock up essentially VMs that looked just like the actual device and would run the code, your most recent commit against that device. And we ran it twice, one on a brand new device that had never been provisioned and one on an existing device with the existing configuration already applied. And that way we're testing both the greenfield and the brownfield to ensure that the devices in the field could also use this update. And then we just moved through the quality gates, right? We would go to a sort of full dress QA environment with a full hardware setup because a lot of our devices were in one structure. And so there's cooperation between devices and you need to be able to test that and have confidence that works. And then once all the PRs have been approved, QA looks good, then you go to production, you do your regular canary and then gradual rollouts. Maybe you do 5, 10, 25, and then 50% of the fleet.
Vinny, do you have anything to add on this?
I think the virtual machines is huge. And in our case, virtual mowers that are mowing virtual grass. But early on, we struggled with this because as a roboticist, it's very tempting to build a full physics sim and okay, what is my LiDAR doing? What is my GPS doing? But honestly, that's too complex. That was unreliable. That was flaky. So what we really did was abstract. What is the simplest thing the mower can do? And that's the virtual machine that our cloud team, our web team interacts with. That's all they care about. And then internally, we want to keep our robot simulation tools separate, right? So our big 2.0 release, we're actually very successful because of that strategy that we newly adopted, like virtual machines that web developers can use because they don't necessarily care about the physics of the world.
And Ali, I'm interested in hearing from you on the developer experience side of things.
Yeah, big plus one to this idea of separating some of the testing. We have a cloud platform and usually the tests run then on a virtual machine because that's often more than enough. But then we have teams that are working on more physical features that do require testing with an actual device. So we have all of similar to what Brian described, like this virtual desktop environment, virtual environment, then actual QA devices. Because we're building a platform, so we're supporting many use cases. We also have different types of canaries just to make sure that they use different use cases and environments where our customers operate are things that we still support over time. For us, it does require to think a little bit about what are our major use cases, what are the conditions they usually tend to operate in, and how can we replicate that as simple as possible and as automated as possible, and ideally without requiring every engineer to have to set up complicated hardware or software, just like a one command kind of situation.
Yeah, that was a great answer. That kind of gets me thinking about the next question, which is how do you balance innovation and experimentation with the need for stability in large scale IoT systems? And if you want to kick it off, because
Great question. I think obviously coming from mostly a background of working on the cloud, for me, this idea of delivering incrementally, quickly, seeing that what you're doing, like delivering a proof of concept is really important. So I think for us that is twofold, right? We have the cloud platform, and in that environment, we can leverage feature flags very easily, and then we can do stage rollouts. And then in our platform that runs in the smart machines, we have a core feature set that we try to change minimally or very carefully. And then we have this idea of modules where we can build any kind of feature and plug it in without impacting the main platform. And that's where we do a lot of our experimentation. And that helps us build confidence of whether the feature will make sense, will be useful, will be reliable, and if it makes sense to bring it in as a core functionality.
Ryan, do you want to take the next?
Yeah, agree strong with everything you just said. I would also say that like this question is the fundamental tension in our world, right? It's like you want to do the DevOps 12-factor app, like high iteration methodology, but you have to interact with the physical world, which is chaotic and difficult to deal with at times. And to me, like the way that we get there is really committing to iterating and moving quickly, but with a number of quality gates. And so making sure that we have a number of checkpoints that we are confirming the functionality of our code, both in, as I mentioned before, in a greenfield and brownfield environment, so that it's not only new devices that are being provisioned on the factory line that work, it's also the existing fleet writ large that is already operating out in physical space.
Yeah, one of the things that you said that was interesting offline was that there's no such thing as 12-factor app in this world. And I'm interested in hearing more about that.
Sure. Yeah, if you think about some of the tenets of 12-factor app, there's a lot, but the one that I think about the most is repeatability. And that is tough in this world because you basically need to have some idempotent mechanism for establishing your configuration policy. In my experience, that was Ansible. You could use an MDM solution. You could use off-the-shelf configuration management. You can write your own configuration management. There's lots of options, but I think the first step into making your will manifest in a reliable way is having this sort of idempotent deployment mechanism so that you can ensure that whether this device has been offline for some period of time, whether this device doesn't have a working real-time clock, whether this device is on, like I mentioned, on the factory floor, that your will is made manifest.
Yeah. Vinny, do you have anything to add?
Feature flags. And I think one thing that's interesting is we actually don't aim to do continuous deployment. It's actually, we don't want to change the physical machine on our customers. That can have safety implications. It can surprise. So we actually try to deploy, but with feature flags, and then we get customer consent. Hey, can we do this? Or, hey, do you want this? The other thing is we can do whatever we want in simulation, right? So having these virtual machines, having our physics-based, having a log replay system, right? So I could collect raw perception data on the robot and build new features on my desktop and say, hey, what would happen if we saw a bicycle on the fairway for some reason?
I love that. So, Vinny, I'm going to kick off the last question that we have with you. As IoT systems evolve, what trends such as edge computing, federated learning, or AI-driven observability do you see shaping the future of reliability engineering in this space?
I would love to see smarter alerting. Tell me what I need to be alerted for. Because yeah, like I can think of things, but then can I write what happened in a ticket system and then have some LLM say, oh, okay, that corresponds with these alerts that I already saw. That's what I would love. That's my request.
Awesome. Cool. Brian, what's your request?
I have two, and one of them's a little dated because it's more like circa like 2017, 2019. But when I was working more closely on the actual metal in this space, ARM for Docker was very nascent and it wasn't really fully baked. So I think in a lot of use cases, not necessarily ours because we had to run X Windows Server and you can't really do that in a container. But for more industrial use cases, being able to Dockerize and containerize just like we do in the cloud on your bare metal, like out in the world, sounds like a great application for Docker. The other thing that is kind of interesting to me, and again, this is more product specific, but we generally had like really strong connectivity. So with Link NYC, like all these devices are connected to gigabit fiber, which is the opposite of IoT. We did have other products that were LTE and intermittent connectivity based, but for Link especially, like one of the things that I was always curious about, and it could be applied to other products, is the ability to basically restore a device from like a totally broken state. So if you have a device that the watchdog has failed, it's not able to boot the operating system, there's a lot of interesting mechanisms to try and restore that functionality. You can do like A/B partitions, like CoreOS used to do, or RPM tree, or just have your own sort of HTTP boot mechanism to restore a device from zero. So that's what I find interesting.
And Allie, I will let you conclude with your requests and what you want to see in the
My request to
future.
the IoT universe. 1+1 to both of your answers. I think maybe thinking a little bit on this recency bias. We have been working a lot with Bluetooth hardware or being in adverse LTE, not super reliable connectivity. And I think, especially when I think about my team and developer experience, being able to test that and replicate those environments is actually very hard, very tricky. And I would love to see like the same level of abstractions that we have for other problems of the real world. I would love to have those abstractions as well for things like Bluetooth or connectivity.
Awesome. Thank you so much for chatting with me this morning. And thank you everybody for watching. Yeah, thanks again.